Okay, so welcome to session number 4. We're just gonna be finishing up what we were working on our last session on Tuesday. So that would just be drilling out all of our holes and tapping some of them that need to be tapped, and as well we'll also be simulating those cutting operations. Okay, so this is what we have so far. On the left side is all the tool paths, and on the right side is what the part is going to look like. But we're also not finished. So if you had remembered, there's holes over here, and there's a counterbore hole over here. So yeah, we have to make those. Okay. So first, whenever we're machining a counterbore hole, we have to follow this procedure. So that would be creating the bore, using an end mill, and then using a chamfer drill, also known as a spot drill or a center drill. We use that to create a spot, and then use a drill to create the rest of the hole. So we'll start with that. So let me go to here. Yeah, so this is the counterbore hole. So we're going to try to machine that first. Yeah, so we know that the counterbore hole is 0.5625 inches in diameter, and it's 0.165 inches deep. So to make this, we're going to need an end mill that has a diameter less than 0.5625. We could use a half-inch end mill, but I think we should use 3/8 end mill because a half-inch end mill has a very similar diameter to 0.5625. So that would mean that like the end mill is pretty much going almost straight down, which is not what we want. We would want it to do multiple radial passes, and we'll be able to do that using a 3/8 inch end mill. Yeah, so that's why we're going to do that. We're going to add a pocketing operation to the counterbore. So, if we want to add a operation to a chain, you click on the chain first. So, the first chain on top is called counterbore. So we're going to click on that. As you can see, the counterbore chain has now turned gray. So that's how you know you've selected the right chain. Then we're going to go to solid mill traditional - solid mill production on the toolbar. We're going to click on that. And then the second option is pocketing. It says review. There's first facing, pocketing, contouring. This third one's contouring. Then something called rust machining, which I'm not too sure what that is. And then there's drilling. And that's what we're going to be using for our holes. But first, we have to create our bore using the pocketing operation. So click on that. And then you'll get the stuff on the left side. In our general tab, we're just going to quickly change our tool and select 3/8 inch end mill. Okay. Then we're going to strategy. We're going to leave it at concentric out. And then our total depth, incremental depth, and starting depth are already been automatically generated based off the geometry of the chain, so that's fine. And then we're going to go to rough. That is where we're going to put our speeds and feeds. So if you remembered, for a end mill, our speed is always going to be set to the max RPM of whatever machine we're going to be using. And so we've pretty much been like assuming we're going to use the VM2, and that has a max RPM of 12,000. So we're going to set that to 12,000. Now, so a quick recap. For every type of feed and speed, there is a first option, and then the comma, and then the second option. So the first option correlates to the first box, second option correlates to the second box. So if you have the RPM, then you put in the first box. And then if you have the surface feed per minute, then you put in the second box. And the same goes for XY feed and Z feed. So yeah, so we've set our speed to be 12,000 RPM. Now we got to figure out what our X and Y feed rate are. And we can do that by going into MFE Labs, clicking on non-ferrous end mills. That would be this one. Oh no, this is a ferrous end mill. Okay, so yeah, we're using a 3/8 end mill. So we're gonna have our XY feed right here, 0.003, and our Z feed, 0.0006. inches per tooth. You see here, it says PT. So, 0.003, and then for a Z feed, it's 0.006. Oh no, sorry, 0.0006. That's going to be our X, Y, and Z feed rate. And then like before, we're going to change our step over diameter to be 25%. Step over diameter, that's just our radial depth of cut. And 24% is what the documentation suggests. So we're going to leave it at that. Then you can just press OK. If you zoom in, you'll see that there's some swirlies, which is pretty much exactly what we want. We're not going to simulate it yet just because of how long it's going to take since of all the other two paths it's going to run for. So we're just going to go through everything else, and then we're going to simulate it, just for the purpose of saving time. Yeah, that's what we had, which is good. And next, we're going to create our spots. So yeah. To do that, we're going to click on the whole chain, which is tool hole. So if you look that the chain called tool hole is this one, and one hole is all of the other ones, all of these, because you can see that they turn gray. But we're going to stick with tool hole because we know that it highlights this one, which is what we want to use. Okay, so now we're going to click on drilling in the solid mill traditional dash solid mill production toolbar. Go back to the general tab and then select the tool, and that's just going to be CM, which is short for chamfer mill, and then it says 0.375 drill mill. Then we gotta figure out our feet and speeds, and that is also going to be on MFE Labs. So if you click on drill mill, which is right here, you'll get to this page, and that's what a drill mill looks like. And then we're going to be assuming we're going to be machining aluminum 6061 T6, so that would be an N2 material group. So we're just going to be looking at this row right here. Our cutting speed is fine. We can just use the max, so we'll set it to 350 surface feet per minute. And then our Z feed rate is going to be 0.0025 according to the website. And then we're going to go to drilling. Yeah. So there's something called cycle type, which isn't too important for spotting because it's automatically going to be set to drill. But we can have pegging operations, which I'm going to talk about later, and then tapping. So you want to make sure you use the right cycle type because that will obviously affect how it's going to machine it. So for now, we're going to leave it as drill. Our total depth, that's just going to be how deep we want our spot to be. And general rule of thumb, you can just leave it as 0.05 inches. That's usually more than enough to lead in a drill. So we're going to set that to be 0.05, and that's our total depth. And you can press OK. Yeah. And that is, so we have first our pocketing operations here at our bore, then we can have this spotting operation. Lastly, we're going to create our hole now. Let's see, we did that. Okay, yes. So we're going to use the same chain called tool hole, and then we're going to click on drilling again. But instead of using a chamfer mill, we're going to use our H drill because if you remember from our second session, we figured out that this hole has the diameter of a H drill. Yeah, so an H drill has a diameter of 0.266, and that's pretty close to a quarter-inch drill. So we're going to be using the same feet and speeds for a quarter-inch drill for simplicity, and usually that's perfectly okay. Then if you want to find your feet and speeds, that would be right here under drill bits, and you're going to see this. So our N2 class, highlighted right here, aluminum cast, less than 10% silicon. And our uncoated, which is typically what we would be using, is 225 surface feet per minute. So we're going to set that right here. Speed 225. go more to the right, this has all of our feeds. So we're going to be using it uncoded like before. And our drill, each drill has very similar diameter, a quarter inch. So we're going to be using those feeds. So quarter inch, and then we're going to go down to N2, and that's going to be 0.006. We set that as, and that is our feeds and speeds for each drill. Okay, then we go to drill. So when making a hole, you either want to use drill or peck. What drill does is it takes the drill and goes straight down in one pass, just like all the way down and doesn't stop. What pecking does, it does multiple like attempts of cutting into the metal. So it goes down, goes back up, and then cuts a little bit more, and it comes back up. So it just incrementally cuts more and more. When you have holes that are deeper, you're going to want to use peck because it helps with chip evacuation and just minimizes the load that you apply on the end mill, especially because this hole is a through hole. It's quite deep, so you're going to want to use a pecking operation. So these peck increments will adjust how deep the drill will go for every peck. And generally you want to keep that equal to the diameter of the drill, and it automatically does that for you. So we're gonna leave it like that. And then our total depth, we're gonna have to figure out because this is wrong. If you look at this drawing, the entire part is 2.5 inches long, and this side pocket is half an inch deep. Then the depth of the hole is going to be 2 inches. And we're actually not going to set our drilling depth to be 2 because of that chamfer that the drill has. So we want to just go a little bit deeper so we can make sure that we go all the way down. So we can do like 2.1 inches, and that should be okay. Press OK. So yeah. So you see here, that's how deep it's going to go, which is good. We want it to go past it. So yeah. So now we can simulate it. If you want to simulate, you want to click on the simulation button on the toolbar, which is the green one. And then you'll have your play, pause, blah, blah, blah. Before we start simulating, I want to go ahead and click on simulation parameters and make sure your collision detection is on full. And then we could speed up our simulations. You can increase these numbers. Let's add like a 0 here. Let's see how fast that goes. And you just press play. I think that's faster than before. And here it comes. See? That's good. It went all the way through. Perfect. Keelan, is this what you have so far?
My computer crashed twice when loading E3 because I spoke too soon, so I'm just on my phone watching.
Okay, cool. I'll just keep going.
Yeah.
Hopefully you'll get a chance to try it on your own whenever you're free. Okay, so we're like halfway there. Now we're gonna go to Tactiles, which is just a little bit more involved. So something that you can do in a spree is copy milling operations and then apply those operations onto a different chain. So we can just click on both. If you hold Control and you click on both, it'll select both, and then you can right click and press copy. And then you click on one hole. This is the other chain that has all of these holes. you can right click that one and press paste. So now what that has done is it added a spotting plus a drilling operation. So our spotting we can leave. Our drilling, however, we want to change that to adjust to the correct tool we want to use. So we're going to switch each drill to number 1 drill. So you remember this is a quarter 20 tap, and the tap drill for a quarter 20 is a number 1 drill. So we're going to use that. And then we're just going to leave the feet and speeds. It's whatever. Then we want to change our total depth because these holes are not through holes, and they're just different depths. So we want to look at the drawings and see how deep they are. So this drawing says they're 2.5 inches deep. So we can set this to 2.5. It's okay. So yeah, now we have spotting and drilling done just by copy and pasting. Very quick and fast. And last thing we want to do is tap our holes. Let's see. Where is it? Okay, here. So we're gonna click on one hole, which is our chain. Then we're gonna go to milling, solid mill traditional, and press drilling. So oddly enough, tapping is also within the drilling one. So we just click on that. Go to general, click on quarter 20 tap. Then speeds and speeds for taps are just I found are quite difficult to find. So I've just been using this chart that I've gotten from the Washburn stuff, and we're gonna be using a quarter inch, and it's gonna be this aluminum cast alloy. So it's gonna be 9.1. Oh no, right here. 60 surface feet per minute. Where's my mouse? Okay, here. I'm gonna change this to 60, and then hopefully you'll remember our Z feed rate is equal to 1 over our pitch. No. Z feed rate is equal to our pitch, actually. Oh, this is a typo. I need to fix this. So quarter 20, it means that the diameter is 1/4, and then 20 is the thread per inch. That means in 1 inch there's 20 threads. And our Z feed rate is, we want that to be our pitch, which is the distance between consecutive threads. So that's gonna be 1 over 20, or 0.05. Then we go to drilling. Instead of drill cycle type, we're gonna switch it to tap. And our total depth is gonna be 2.5, just like before. And then we're gonna press OK. I remember there was. It's okay. Now we're just gonna run it. Let me see if I can make this even faster. It takes a long time. Oh, there we go. It's fast. I don't know why I did that. Maybe it's too fast? That shouldn't matter. What? Okay, whatever. We're just gonna keep going. Okay, so yeah. So it's just gonna tell you there's a simulation error, but it's not a big deal. It's just because the drill size is just cutting into the insides of the threads, which is nothing you can do. So in this case, you can just press the skip button and just spam it. Yeah, well, the only issue is that the drill is too short, so look right here. The 2 holders going into it, but we can change that. And it's gonna keep spamming it through. There's a lot of holes, so you can click it a lot of times. And now it's tapping, and it has an issue again because it's hitting with the 2 holder and it's cutting through the inside of the threads, but not a big deal. We can just go ahead and just change. So we either use the number 1 drill. We're gonna change the tool length to be like 3 inches, and we're gonna do the same thing for our 1/4 20 tap. Yeah. So I don't know why it's doing that. I feel like it's just not knowing it's the problem. But yeah, it's gonna keep telling you there's an error, but there's no error. It's just not very smart. But yeah, that is how you do drilling in CAM.
Thanks for the lesson.
That is all that you have to do for this part, and you're all done. Don't mind the blinking red, it's fine.
Should have an epilepsy warning at the beginning of this.
Do you have any other questions?
Not really.
Okay.
I don't. I think it's the VPN's fault that might.
That is probably why.
Alright.
I've had a lot of issues with like connection problems, things not loading because of having the VPN on.
Alright.
It's not very great.
Yeah.
Yeah, I would just try it again tomorrow or some other time.
Yeah. Well.
Okay, well, if you don't have any more questions, I'm gonna stop the recording and I'll be it.
Alright. Cool.